In this video, we're going to talk about properties of logarithms and the change of base formula. So the learning targets for this video, we're going to apply the properties of logarithms in any base. We're going to compare and expand logarithmic expressions, and we're going to use the change of base formula. And that change of base formula is going to help us out to plug in any logarithm that we want into our calculator, as long as we can convert it into one of the bases that we see in our calculator. Right now, you can only do log base 10 and log base e, or ln, in your calculator, because that's what's in your calculator. But we're going to talk about how we can change the base, no matter what base it is. We can change it to 10 or e, and we can plug it into our calculator. That's the first thing we're going to talk about. So, to evaluate logarithms with any base, you can rewrite the logarithm as a quotient of two logarithms with the same base. And the formula for this is, if I have log base b of a, base b of some answer, I would rewrite it as, I would do a quotient log base c, that's whatever base I want, c is whatever I want it to be, it's usually 10 or e, of a, divided by log base c of b. It has to be the same base in the top and the bottom. With this formula, to remember how it goes, a comes before b, so a is going to be on top of b. You can remember that. A goes on top, b goes on the bottom. You can just remember b goes on the bottom, b for bottom. And then c can be whatever you want it to be. C can be whatever base you want. It's usually 10 or e, because those are the ones on our calculator. So c can be any base. The common logarithm and the natural log, those are log base 10 and log base e. Those are the ones we usually use, we convert to. So we use c as 10 or c as e, like I just said, because those are in our calculator. So the common logarithm, that's log base 10 of x, or just log of x. And the natural log, so that's log base e of x, or in your calculator it's ln of x, are usually used because these are in our calculator. These are in our calculators. So, for example, what is log base 4 of 8 written as a quotient of two logarithms with base 2? If I wanted to convert log base 4 of 8, I would convert it into this is my base, this is my answer. I want to convert to base 2, so I'm going to do log base 2 on the top and the bottom. On the top, I'm going to plug into that logarithm 8, because that's my answer. That's my a goes on top. And on the bottom, I'm going to plug in 4 into that logarithm, because that's my base. b goes in the bottom. And what I get with that is I can solve this. So this is also a way to solve logarithms easier sometimes. I'm asking myself, what do I raise 2 to get 8? And that is, in the numerator, I'm going to have 3. 2 to the third power gives me 8. And then the bottom, I have 2 to what power gives me 4? And that's 2. So my answer, I don't even have to put this in my calculator. I can't put it in my calculator because it's log base 2. But I have 3 over 2 as my answer. Okay, but most of the time, we convert to base 10 or base e. I've already said this like 17 times. And I'm going to go over that now. So what is log base 4 of 8 written as a quotient of two logarithms with base 10? So let's do base 10 first. That's log of x in our calculator. This is the common log, in case you forgot. Too many parentheses. I have log base 4 of 8 is equal to, I want to convert to log base 10. So I'm doing log base 10 in the top and the bottom of my quotient. I am going to have 8 is my answer. 8 is my answer, so that goes on, that I plug into the log on top. And b is my base, so I plug that into the log in the bottom. And I'm gonna get, and I can do this in my calculator. I can do, this is just, oh my gosh, that scared me. Log of 8 over log of 4. I don't have to write the 10. In my calculator I do this, and I get log of 8 gives me 0.903089987, and continuing on and on and on. In the bottom I have log of 4 is 0.602059991 ... and this gives me 1.5 when I do it, which is about 1.5 if I round. And that's what I had in up here. If I use the exact numbers, like I use answer divided by answer in my calculator, I will get exactly 1.5. Okay, I did not leave enough space. I'm gonna move this over here. The next thing I'm gonna do is base E. So I'm gonna convert to base E. I can do that as well if I want to put something into my calculator. This is the natural log, and it's ln of x in your calculator. I'm gonna do log base 4 of 8. So I'm gonna do ln over ln. Ln of, that's log base e of 8, log base e. I'm gonna put my answer in the top and my base in the bottom, log. And if I do that in my calculator, I can do ln of 8 divided by ln of 4 without calculating what each one of those is, and it gives me 1.5. Okay. All right, so no matter what base you convert to, you're gonna get the same answer. All right, so I wanna use the change of base formula to evaluate each one of these expressions. I have log base 4 of 32. These two things, 4 and 32, share a base in common. So the easiest one for me to use, I mean, this probably still 10, but I'm going to convert this to the base they share in common, which is 2. So I'm going to change this to log base 2 over log base 2. I'm going to put 32 into the top one. That's my answer. And then I'm going to put 4 into the bottom logarithm. And I'm going to get 2 to what power gives me 32? That's 2 to the 5th power. 2 to what power gives me 4? That's 2. So my answer is 5 over 2, or 2.5. For the second one, I have log base 3 of 5. Those don't share a base in common. So I'm gonna do base 10 and put it into my calculator. So I'm gonna do log over log. My answer I plug in on top. Oops. So 5 I plug in on top, and 3 I plug in on bottom, and I get, when I do this in my calculator, I can do log of 5 divided by log of 3, and that gives me about 1.465. Then for number 3, I have log base 2 of 15. 2 and 15 don't share a base in common, so again, I'm going to use log. Actually, I'm going to use ln for this one. So I'm going to do ln on the top and bottom. I'm going to do 15. That's not what I meant to circle it with. I'm going to do 15 on top, 2 on the bottom, and that gives me, if I do it in my calculator, ln of 15, oh gosh, ln of 15 divided by ln of 2 is 3.907. All right, for number 4, I have log base 6 of 17. These don't share anything in common either. I'm going to do log over log. I'm going to do 17 plugs into the top one, and 6 goes into the bottom one. And when I do that on my calculator, I'm going to get 1.581. For number 5, I have log base 6 of 10. 6 and 10 don't share a base in common, so I'm going to, again, do log over log. That's log base 10. I'm going to do 10 goes in the top, 6 goes in the bottom. I get, when I do this on my calculator, 1.285. 5. For 6, I have, I'm going to do ln of 6 over ln of 5. And when I do that in my calculator, I get 1.113. For number 7, I have log base 8 of 1. 8 to what power gives me 1? I don't need to do anything. This is 0. 8 to the 0th power gives me 1. For this one, I have, I'm doing log of 11 divided by log of 100. It equals to, when I do this in my calculator, 0.521. Next page, I have the product property, the quotient property, and the power property. We talked about those already. We talked about condensing. We're going to talk about today expanding. So we're going to expand these using these properties. Before we had this, and then we went to this. Now we're starting with a condensed logarithm and going to expanded form. So we're going to, if we see multiplication inside, we're going to change to, we're going to separate and write addition in between. If we see division, we're going to separate and subtract in between. If we see an exponent, we're going to make that the coefficient, or we're going to multiply by that logarithm. So if I wanted to expand log of xyz, I know that this is between all of these. They're being multiplied. This is multiplication, which means I'm using that first, I'm using this product property. And I can write this as log of x plus log of y plus log of z. I can separate it all. And this is what I have in expanded form. All right, for number 10, I see log base 2 of x divided by y times z. So I see division inside, which means I'm going to use this quotient property. And I'm going to separate the logarithms with subtraction in between. I know it's base 2, so I have log base 2 of the numerator, x, minus log base 2 of the denominator, which is y times z. I can simplify this a little further. This logarithm, log base 2 of y, z, can break down further because there's multiplication happening in between the y and z. So now I can use the product property again. I'm going to take log base 2 of x, and I'm going to subtract. I'm going to put this in parentheses, so I know to distribute the negative. Log base 2 of y plus log base 2 of z. And I know I have to distribute this negative to both of these logarithms. So I'm going to have, when I simplify this all the way, log base 2 of x minus log base 2 of y minus log base 2 of z. Don't write plus log base 2 of z. Make sure you distribute that negative, and that's my expanded form. For this one here, I have multiplication happening in between all of these things. So I'm going to separate it with addition. I'm going to do log of 6 plus log of x to the third power plus log of y. For expanded form, you cannot have exponents for expanded form. So expanded form equals no exponents. For condensed form, no coefficients. So you can remember, condensed, no coefficients, expanded form, no exponents. There's an exponent here I have to get rid of. I make it a coefficient instead. I know I can write now log of 6 plus 3 log of y, log of x, using the power property. I can take that exponent and make it my coefficient. And then I have plus log of y, and that's as much as I can expand it. So I'm done. For number 12, I have log of 7 times 3x minus 2 squared. First thing I need to take care of is the multiplication I see between 7 and 3x minus 2 squared. I'm going to break this down with addition, so I'll do log of 7 plus log of 3x minus 2 squared. And from here, I know that I can't have exponents in my expanded form, so I need to move this to be a coefficient instead. So I have log of 7 plus 2 times log of 3x minus 2, and that's as much as I can simplify, because you can't break things down when there's subtraction inside of the logarithm, only multiplication, division and exponents. All right, for number 13, I have log of 5x divided by log of 5x divided by 4y. This is division, so I know I can separate with subtraction. So I'm going to do log of the numerator, 5x, minus log of the denominator, that's 4y. And I'm going to simplify this. That 5x is inside of the logarithm, 4y is inside of the logarithm. 5 times x and 4 times y is what I have inside of these logarithms, so I can separate these further. This first one, log of 5x, can break down into log of 5 plus log of x. So it breaks down further into log of 5 plus log of x. The other one, I'm going to put this in parentheses, breaks down into log of 4 plus log of y. I need to make sure I distribute, the negative to both of these logarithms, log of 4 and log of y. And when I do that, I'm going to get my final answer is log 5 plus log x minus log 4 minus log y. And this is my answer in expanded form. Number 14, I have log of the square root of 2rst over 5w. Oh my gosh. First thing I want to do, there is an exponent here for everything, and I'm going to rewrite this so I can see what that is more clearly. I have 2rst over 5w raised to the 1/2 power. If I'm taking the square root, that's the same as the 1/2 power. If I'm taking the cubed root, that's the same as the 1/3 power. If I'm taking the fourth root, that's the same as the 1/4 power, etc. Fifth root, 1 over 5. So I can change that whenever I see in condensed form, I see this, I have to change it to the expanded form. I got to change that square root or whatever root it is to a fraction exponent. Now I can see that I can take this exponent, and I can make it be coefficient. So I can do 1/2 times log of 2rst over 5w. And I know this is division, so I could break it down. I have 1/2, and I'm going to put 1/2 on the outside, log, because I'm going to distribute it. I have log of 2rst minus log of 5w. I'm going to break this down further. This is all multiplication, so I can separate it with addition. I'm going to have 1/2 log of 2 plus 1/2 log of r plus 1/2 log, log of s plus 1/2 log of t minus this, I'm going to put in parentheses. When I break it down, log, it's going to be 1/2. Everything, I distribute that 1/2 to everything. So it's 1/2 log of 5 plus 1/2. I'm just going to distribute it without, so I don't have to write this all over again. 1/2 log of 5 minus 1/2 log of w. And this is my answer. Oh my gosh, that's crazy. In the last video, we talked about condensing logarithms. We're going to do more practice with that. So if I have expanded form, I want to go to condensed form. The opposite of what I just did is what I'm going to do. So I have log base 5 of 4 plus log base 5 of 3. That is addition in between, which means I can condense them, since they have the same base, to be log base 5 of 4 times 3, or log base 5 of 12. I can't simplify that further, so I'm going to leave it as log base 5 of 12. For 16, I have log base 6 for both of these and subtraction in between. So I'm going to have log base 6 of 25 divided by 5. That's log base 6 of 5. And I can't simplify that further, so I'm going to leave it like that. I could get, if it asks me to round to the nearest something place, I can actually calculate what that is now using the change of base formula in my calculator. But we're going to just leave it like that for now. For 17, I have all of these have 2 as their base, so I can condense them. I'm going to condense reading left to right, so I'm going to do log base 2 of 4 plus log base 2 of 2 is log base 2 of 4 times 2. So I have log base 2 of 8 minus log base 2 of 8. Ugh, that's a 0. All right, for 18, I have 3 times 4 times log t squared. I know that first thing I'm going to do is I can't have in condensed form coefficients, so I'm going to make that an exponent instead. So I'll have 4 log t squared, and t squared is going to be raised to the 3rd power, so I'm moving that to be the exponent of t squared. And I'm going to end up with another coefficient. I can't have that, so I'm going to have to take this coefficient and make it another coefficient. I'm going to simplify first, so it's not too crazy. I'm going to have 4 log of t to the 2 times 3, so t to the 6th power. Then I'm going to take this coefficient and make it an exponent. So I'm going to actually have log t to the 6th power raised to the 4th power. And then that is finally log of t to the 24th power, and that's my answer. Done. For 19, I have log base 4 of 60 minus log base 4 of 4 plus log base 4 of x. All of these have 4 in common. I'm going to read left to right. So I'm going to do log of 4 times, log base 4 of 60 divided by 4 plus log base 4 of x. And from here, I'm going to, 60 divided by 4 is 15. I have log base 4 of 15 plus log base 4 of x. So I end up with log base 4 of 15x. And this is condensed form. I have no coefficients. I'm good and done. For 19, I have log base 7. All of these are not log base 7. Log base 10 for all of these. So I can combine all of them. I'm reading left to right. This is log of 7 divided by 3 plus log of 6. I'm going to multiply these now, so I'll have log of 42 divided by 3. And I can simplify that to be log of 14. Whoops. 42 divided by 42 divided by 3 is 14. I want you to try these on your own. Try these on your own. For 21, I have 2 log of x minus 3 log of y. And first thing I know, in condensed form, I can't have coefficients, no coefficients in condensed form. So I have log of x squared minus log of y to the 3rd power. So I took these coefficients and I made them exponents instead of what was inside of the logarithm. Now I can combine these. There's subtraction in between, so I know I can do division to combine. So I have log of x squared divided by y cubed, and this is my answer. For 22, I have no coefficients allowed. I need to start by moving those. So I have log of r to the 1/2 power, that's the same as taking the square root, plus log of s to the 1/3 power, which is the same as taking the cubed root, minus log of t to the 1/4 power, which is the same as taking the 4th root. So I have log of t to the 4th root, or the 4th root of t, sorry. And now I can combine reading left to right. I have log of the square root of r times the cubed root of s minus log of the 4th root of t. And there's subtraction in between here, so I can combine with division. the square root of r times the cubed root of s all over the fourth root of t inside of the logarithm, and this is my final condensed logarithm. For number 23, I have log base 3 of 4x plus 2 log base 3 of 5y. First thing I need to do is get rid of this coefficient. So I'm going to make this an exponent for 5y. And it's everything inside of the logarithms. So I'm going to have log base 3 of 4x plus log base 3 of 5y squared is 25y squared inside. And now I'm going to combine these. There's addition in between, so I'm going to combine by multiplying everything inside. I'll have log base 3 of 4x times 25y squared. And that's a total of, inside I have 100xy squared. And this is my answer. No coefficients in condensed form, I'm good. And just a single logarithm. For this one, I have 5 log of 2 minus 2 log of 2. I need to make these coefficients exponents first and foremost. I'm going to have log of 2 to the 5th power minus log of 2 to the 2nd power. I have subtraction, so I'm going to divide. I have log of 2 to the 5th power divided by 2 to the 2nd power inside. That simplifies to be log of 2 to the 3rd power, which is just, log of 8. For 25, I have 1/3 log of 3x plus 2/3 log of 3x. What I'm going to do is I'm going to take these coefficients and make them, I'm going to take these coefficients and make them exponents. So 2/3 is going to be in the exponent for 3 to the x power. I'm going to have log of 3x raised to the 1/3 power. That's the same as taking the cubed root, so I'm just going to write the cubed root. Let me write this better. So I'll have log of the cubed root of 3x plus the second one will be log of 3x to the 2/3 power, so I'm squaring it and then taking the cubed root. Now to combine these two, I'm going to have log, there's addition in between, so I'm going to multiply. I'm going to have the cubed root of 3x times the cubed root of 3x squared, and that's going to give me log of the cubed root of, I can combine these since they're both cubed roots, that's 3 cubed times x cubed. The cubed root of those is just 3 and x, and I have log of 3 of x. No, log of 3x. And then for 26, I have 2 log of 4 plus 2, both log of 2 plus log of 2. This is log of 4 squared plus log, this is 2 log 2. And I can make that log 2 squared. So I have log of 4 squared plus log of 2 squared. This is log of 16 plus log of 4, which is log of 64.